Right, we're talking about recursion. So just a reminder, recursion is what happens when a function calls itself. Or we'll see later on, when two or more functions call each other. But at the moment we're talking about self-recursion. It is a really useful technique in mathematics and computer science of solving some problems. Sometimes you'll be given a problem to solve with recursion, but other times you'll just be given the solution and asked to translate that to Java. And those are the examples we're looking at. So factorial in mathematics is defined in factorial, that's exclamation mark, this notation is defined as n times n minus 1 times n minus 2 times dot dot. And we can also write this as what is called a recurrence relation. So if we just cover the n, we'll see that this part of the definition is really the value of n minus 1 factorial. So we use that and say the factorial of n is either 1 if n is 0, or otherwise it's n times the factorial of n minus 1. Just working from this original definition. And we can easily write that as Java code. So public static int fact n. If n is 0, we send back a 1. Otherwise, we send back n times the factorial of n minus 1. So you can see that this is a one-to-one translation of the definition, the mathematical definition. Let's see. Factorial of 4. So that's 4 times 3 is 12. Times 2 is 24, times 1 is 24. So we expect this to display 24. And if we run it, save and run, we see it prints 24. Okay, so I just straightforwardly translated the definition I was given. Our next example is GCD, which stands for Greatest Common Divider or Divisor. And in mathematics, this solution is called Euclid's algorithm because Euclid, the Greek mathematician, invented this. And once again, we're just given the recursive relation. The GCD of A and B is either A if B is equal to 0, or it's the GCD of B and A mod B. So once again, we can translate that directly to Java. Here we go. So public static int the GCD of A and B. Well, if B is 0, then this is simply A. And else, it's the GCD of B and A mod B. Oh, mod, I write it down. Mod B. There we go. So you don't have to understand this, although it's not hard to do that. But for now, we'll just accept it and write it. Look at the big difference between GCD, where the otherwise value is just a pure recursive call of this function itself, but with modified parameters. Because if we pass the same parameters, the very same thing will happen and this recursion won't terminate. And here we actually also, the factorial function also called itself, but it modified the result a little bit. So there's a little difference we see. Also important is that both have a termination condition. There's both some case where the recursion stops. So let's see how GCD works. GCD of, and I'll just pick two numbers, 385 and 66. Let's run that. Aha. So the greatest common divisor of these two numbers is 11. Right. And the last example we look at is something called the Fibonacci sequence. You may have heard of this. It's a sequence of numbers that starts out 1, 1. And to get the next number, we add these two numbers. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on. And we can write that as a recurrence relation. The nth Fibonacci number is 1 when n is less than or equal to 2. So if it's 1, if n is 1, the answer is 1. If n is 2, the answer is 1 as well. And otherwise, the Fibonacci number is the previous number plus the number before that. The number that comes in position n minus 1 plus the number that comes in position n minus 2. So we can write that in here. Public static int for nth number. Well, if n is less than or equal to 2, then the answer is 1. Else, the answer is the n minus 1 Fibonacci number plus the n minus 2 Fibonacci number. Okay, and let's see what the 20th Fibonacci number is. I don't know. Okay, let's save and run. 6,765. So if you keep on going with the sequence, eventually you come to 6,765 in position 20. These are very simple examples of the recurrence relation that we are given. We translate it to Java, and when we run it, this program will use recursion. This function does call itself, and it has a termination condition, which is very important. And also, when it calls itself, it needs to modify its parameters because otherwise we won't terminate either. Good.